Welcome to the video lab. We're going to be going through the configuration process for an iOS-based DHCP server and cover that here so that you're familiar with how to do that. Now let me talk for just a second about iOS-based DHCP servers and why I think you should do them. I know that it's kind of a natural thing in a smaller environment for the Windows administrator to spin up his domain controller and turn on DHCP on his server. I don't really subscribe to that methodology. I think of DHCP as a core infrastructure service. And as such of a service, I want it on a core infrastructure device, i.e. a router, a layer 3 switch, something along those lines. So what I do is I'll most often use my core switch or my user distribution switch, or whatever your topology calls for. Sometimes it's the access switch, if you're routing down to the access layer. But I want a network infrastructure-centric device to be doing my DHCP services. So I'll stop preaching. That's why I do it this way. And Cisco will expect you to know how to do this for your CCNA voice certification. So here's what we're building. VLAN 20 exists on our switch, and it's got a name of HQ phone. So we're going to build a DHCP pool and give it the same name. We're in the 10.10.200.0 subnet, which is a /24 or a 255.255.255.0 mask. Our DHCP pool, or the range of addresses we're going to hand out, is 10.10.200.100 through 120. And we're going to, as part of our DHCP pool, hand out the TFTP server IP address. This is my call manager publisher. So let's go through this. And in fact, port FA04, I've got a phone hooked up, and I've got the port currently in shutdown mode. We'll turn him on, and so you can see a DHCP request and the whole process take place. So without further ado, let's build a DHCP server. So config T on my switch, and I forgot to say, you want to do this on a router, that's fine. I'm doing it on a switch. The process is the same, so don't worry about that. So config T, and I'm going to, first thing I'm going to do, and you don't have to do it in this order, but I like to do the excluded addresses first. We'll say IP DHCP excluded address 10.10.200.1 through 10.10.200.99. Remember, our pool is going to start at 100, so we want to exclude everything up to 100. And then anything after 120, so 121 through 10.10.200.254. So basically we've carved up 100 through 120, and we've created the exclusion ranges to do that, which is, if you're a Windows administrator and you've done DHCP on a Windows server, you'll realize that on a Windows world you define the pool, in Cisco you define the exclusion ranges, and the pool is anything you haven't excluded. So let's create the pool. IP DHCP pool HQ _ phones. We will tell it what our subnet is, network 10.10.200.0, and you can either do a slash here or the network mask. So we'll say 255.255.255.0, and we'll say, let's just pick I don't need it, but I'll show you how to do it. DNS server 4222. That happens to be a public DNS server. If you had one in your enterprise, you'd point to that. We will say default router, which is the default gateway we're going to advertise, as 10.10.200.1. And here's the one that matters. Here's the voice command. Option 150 IP 10.10.210.10. That's my publisher. So if I do a show run, we'll show you what we've got going on here. And you can ignore the other pool I've got going on. But we've got IP DHCP excluded address for .1 through 99 and .121 through 254. So we've framed around this pool that we're looking at. And we've got the pool down here, IP DHCP pool, HQ phones. We've defined the network. We've defined a DNS server to hand out. We're going to hand out a default router, and we're going to hand out that option 150 IP. So since my phones are on the same subnet as my DHCP server, there's nothing else left to do. Now, there's this thing called IP helper, and it's not terribly important from a CCNA voice perspective, but it is important to understand. If your DHCP server is on a different subnet, you'll need to do an IP helper address on the VLAN routed interfaces so that those broadcasts can be forwarded as unicast to the DHCP server. But I'll leave that as an exercise for the reader to understand. It's not something I'm seeing a lot in the field anymore. People did it kind of in the early days, and now people are kind of siding with me and saying, let's keep the DHCP server closer to the phone. So I'm not going to go off on a tangent too much there. So we've defined our excluded addresses here. We've created the pool, and let's do a clear IP DHCP binding, and we'll say, actually, you know what? I don't have any bindings for that subnet. I'm going to look at them. Show IP DHCP binding. I shouldn't have any 10s. No, I don't. So since I don't have any 10s, this will be the first one. We'll say, first I'm going to turn debug on. Debug IP DHCP server, and I think it is events. Yeah, we'll use the events debug. You could go packets, but it's a little more granular than you need. And you may see another device, asking for DHCP out here. It's kind of hard to time it. This is a network that's live. So we've created the DHCP server, and you can see something actually asking for 10.10.2.10s. But we won't worry about that. We'll say config T interface FA04, which is where our phone is, and we'll say no shut, which will bring that phone up. Again, ignore the 10.10.2.10s. We're looking for a 10.10.200 request from a phone with a MAC address ended in what? I think 7 Charlie. Here we go. So it would have happened a little bit quicker had I not already had an address on that device that we had to turn away. So we can see we've assigned an IP address 10.10.200.100 to the client, ending in 7.3. And we're giving it, some information here. See which address we gave it. And really, we can turn our debugs off. That was pretty straightforward. The phone now has an address. So ping 10.10.200.100. It responds to us. It hasn't yet registered with the call manager. That'll take another moment. But if I do a show IP DHCP binding, you'll see in the DHCP pool 10.10.200.100, and we've assigned it to that host. And that's the basics right there of a iOS-based DHCP server. I know that you had a little bit extra garbage to wade through on the debug because of stuff on other subnets, but hopefully this gives you a little better understanding of what to expect when configuring an iOS DHCP server, and kind of how to troubleshoot it. The debug commands are kind of helpful. Let me show you again what's configured. We'll say show run, and the only thing we set up here was we set IP DHCP excluded address 10.10.200.1 through 99 and 10.10.200.121 through 254, and then we created a pool, IP DHCP pool, HQ phones. We said network 10.10.200.0. We put the mask in. We gave it a DNS server. It wasn't necessary, but it's a good practice and something we should do. And we gave it the default router, 10.10.200.1. If we didn't give it a default router, we'd have a little bit extra ARP traffic going on there. That's not something we want. And we gave it the IP option, number 150, pointing to the boot server. And actually, as I look across the desk here, I can see that the Cisco phone is up and in service, and everything's happy. So with that, you now know how to configure an iOS-based DHCP server. And the next video, we're going to talk about how to configure NTP services on a Cisco device. NTP is one of those things, especially when you get into SIP endpoints, that you're going to need to have an NTP server on your network. And really, you're going to need one anyway. When you're spinning up a call manager, etc., it's going to look for the existence of an NTP server on your network. So it's going to have to be there. So we're going to cover that in the next lab and give you a little primer on network time protocol. So for now, that'll do it for this video, and I'll see you in the next lab. Thanks, guys, and good studying.